block 1, block 2, block 3, and henceforth. Design consideration, eligibility. Eligibility should embrace age restrictions and nationality of the citizens. Anonymity, the name of the voter should not be revealed. Records unchangeable, that is, the record should not be changed or the vote should not be tampered with. Single cast means that every voter should get only one chance to vote in one election. Authentication means that every voter should have their registration done before the election and have an electoral card. Transparency, there should be transparency between the election officials as well as the citizens of the country. Properties of blockchain. Smart contract. Smart contract is a small code which is embedded on the blockchain. Every node of the blockchain has a copy of the smart contract, and this is enabled through a message which is embedded in the transaction. Asymmetric cryptography, which is a pair of public key and private key, in which public key is shared with all the nodes in the blockchain and private key is kept secret with all the nodes in the blockchain. These two keys are used to encrypt the data, in which it would be protected from any unauthorized intervention. Hashing is an unidirectional algorithm in which the transactions are encrypted and they form an uniquely identified hash which is placed on the header of the next block. If the transactions of any of the block is changed, then the hash code of that block would change and all the consecutive blocks. Then consensus protocol. In consensus protocol, it is an algorithm which aims at finding a common agreement. We are using delegated proof of stake, in which the stakeholder gives the authority of creating the block to their favored delegate. This is
Please continue.
Affordable and highly efficient as compared to POW and POS. Process. At least the voter should be a proof of their nationality and date of birth. Blockchains used are private blockchain, that is where the nodes of all the voters are connected. That is, the votes of all the voters are connected. This
Sorry for the interruption, Shreya.
would
Just have 2 minutes left to conclude. Shreya.
There are some requirements which are not audible. At least the voter should be registered once it's
Hello, Shreya.
Ma'am will move on with the next presentation. Is that fine?
Well, let her complete because.
Yeah, I should be able to at least give a presentation like for this part.
Yeah, please continue.
And even question station is like it has not been conducted, right?
Just have 3 minutes.
Okay, yeah. So yeah, sure. Then an opportunity to create a block in the blockchain. The voter would be displayed with a list of candidates. The voter can vote for the favored candidate using his wallet. For using his wallet, he would use his private key and he would share his public key with the favored politician. Now the transaction along with so for data, and hence all the voters observe while the voter can see his transparency is maintained. Now, for this, the rigidity of the system results in increased participation of the voters. That is, the voters which are not present in the constitution cannot vote for their leaders. But
Shreya, sorry to interrupt you, but you are not clearly audible.
against the biometrics in the QR code, then the session will cancel
Hello?
this part. And even my questions. Yeah. Should I repeat? Hello?
Voice is not coming properly. I'm not
Yes.
able to hear it.
Just hello? Just a second. Wi-Fi is connected. Can you hear me now?
Yes, yes, you can
Yes.
conclude with
Hello?
your conclusion.
Yeah. So validation, verification, consensus, and immutable recording leads to the security and trust of the blockchain. Hence, we have proposed the cryptocurrency wallet in our protocol. Now, features of blockchain such as smart contract, consensus, and hashing render the blockchain immutable. Through blockchain, we make the election system decentralized and hence preserve democracy. These are the references which we have referred. Thank you so much.
Thank you, Shreya. Thank you for the presentation. Any questions now?
Yes.
Hello, Shreya.
Yes, ma'am.
Yeah. Can you differentiate between security and privacy?
In the blockchain,
Yeah.
yeah, for the security, the hash, if like the votes are changed, the hash would change. But for privacy, just a second, in this, the privacy is maintained. That is, the anonymity of each, like the other voters is maintained, but for the voter, he can see his own details of the blockchain. So that is how I can differentiate both of them.
Okay, thank you. Thank you so much.
I want
Private blockchain, that is a
to ask a
votes of all
question.
the voters are connected in. Yes.
You have not included the review of literature part. Means you have proposed the system. How is it different from the work which is going on right now?
Yeah. So basically, we have included that in our system, any voter which is not present in his constituency would also be able to vote. So basically, their votes would be laid in a smart contract, and these smart contracts can be traded between the authorities which are there in the boot node, right? So that's how the people can vote for their like respective free resident in that constituency. I hope I've answered your question. Like, if you want me to give any further explanation,
I just wanted to ask how your work is different from the others' work.
hello.
Hello, am I audible?
Yeah. You
Work
are.
is
You are.
different from other. How your work is different from
The
others, from
cryptographic
other
wallet.
research.
Like, yeah, this is the factor which I've added. I have not found this factor in any of the research papers I have referred, at least. So yeah, that is that about it.
Yeah, thank you, Shreya. Thank you for the presentation. We move further now.
Yeah.
Thank you.
Okay, thank you.
Do we have Sai Surya Kiran Pokla? I've
Yeah,
unmuted you.
yeah.
You can begin with your presentation.
Okay, I'm starting presentation.
Yes, please.
Is it visible now?
Yes, yes. You have 8 minutes to complete your presentation.
Okay.
Please stick on to the time schedule. Hello?
Is it audible?
Yes, it's audible and it's visible as well. You can begin.
Okay.
Hello. 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 Sai Surya.
Yeah, yeah.
Please begin, sir.
Okay, okay,
This, yep, the slide is visible. You can
okay,
start with the presentation. Faster, please.
okay. Hel- Wait, wait. Just 1 minute, just one sec, one sec. Okay. Hello everyone. I'm Sai Srikaran and I'm going to present topic on a low-cost IoT enabled device for a real-time air quality monitoring system. My objective, sir, like to create an IoT device to monitor the quality of air and to analyze the air quality data and provide information to the clients. And it also evaluates the quality of air by comparing the levels of harmful gases with the threshold value. And we can facilitate the users by notifying them a message or an email if the threshold if the values of gases reaches the threshold. And outline of the talk contains introduction, problem statement, and survey, proposed scheme, experimental setup, and results, and concluding with conclusion and future work. Like, like an introduction, like nowadays in the metropolitan cities, due to industrialization and urbanization, measuring air quality is very necessary to take preventive measures and to reduce the air pollution. To track the effect of this large number of urban vehicles on the environment and on the health of individuals, it is better to track pollutant levels in the urban and suburban areas. With the results of monitoring, government can make informed decisions about how the environment will affect the society and how the society is affecting the environment. The levels of harmful gases such as sulfur dioxide, carbon monoxide, and ammonia, benzene, and these type of harmful gases are increasing day by day. And increase in these vehicle uses also gives rise to an increase in traffic related polluted emissions. And the tracking of these gases is very necessary in order to determine the quality of environment. And in this situation, the IoT is a network of objects in which the objects of everyday life are embedded with microcontroller, sensors, and software that enables these objects to collect and communicate data with another. And a problem statement, like air pollution is a major concern in many metropolitan cities, and inhaling these air pollutants for a long time causes diseases and damage in human health. And extremely growth in these industrial area frameworks, and these are creating environmental effects like atmospheric changes and pollution. Like traditional air quality monitoring methods such as air quality station monitoring stations are typically expensive and related work. Like my my work contains of survey of 20 papers, research papers. The monitoring of urban air quality through mobile sensing is a popular topic, especially with possible applications of designing, deploying, and administration of wireless sensor networks that measure gaseous pollutants from various urban scenarios. The system is suited for a wide variety of applications related to environmental monitoring. For this system uses Raspberry Pi as a base station and XB as a networking protocol and number of open source software packages. This paper presents an architecture and a software solution for environment monitoring using sensor nodes, which can communicate with Wi-Fi module and networks. And two different architectures of smart coordinator based on a Raspberry Pi with and without an Ethernet border, router from embedded computer, and wireless network coordinator were implemented. And this web information system is provided and a wireless sensor network for indoor or outdoor air quality monitoring. It also, one of the paper proposes that a wireless sensor system is developed by using open source hardware platforms such as Raspberry Pi and Zigbee. Zigbee is a Bluetooth to send data. And two different and a three-tier architecture is used for the IoT device that detect the levels of harmful gases and they transmit the data through the cloud platform by using the Wi-Fi module, which is ESP8266. And the data is analyzed in the cloud platform. The experiments resulted in an increase of ozone concentrations near the polluted areas. For every 5 minutes, sensor data is transmitted to the cloud using Bluetooth connection. And this is the overview of the proposed system, which is shown in the figure. And it is designed to monitor the quality of air. The major components involved in the system are Arduino, Wi-Fi module, sensors, and the sensors connected to Arduino, sense the levels of harmful gases in the air. The proposed system provides an user interface to the clients, and it sends an alert to the users when the levels of harmful gases are increased. And Arduino is
Sorry
soft.
for the interruption. You just have 2 minutes left to conclude.
Okay. Then okay. Uh, the API key is used to connect the Wi-Fi module with the cloud platform. Data is received within 17 seconds, and results are monitored and accessed remotely from web pages. The monitoring results can be viewed on a web page provided by ThinkSpeak Cloud Service. Data can also be converted to Excel data or XML or JSON format. In order to deploy a scalable and cheap air monitoring system, we propose an efficient and scalable platform that enables users to monitor their daily exposure to air pollutants by giving air quality information provided by heterogeneous provided by this figure. And the workflow goes like this. Our workflow for the system. Like first, we initialize the Arduino, and the sensors are connected to it, and the process of sensing the data from the sensors are triggered by considering the average of sensor data for 6 hours, and the data is compared with threshold values. Data is compared with threshold values. Depending on the reading of sensors, the notification will be sent through a text message along with an email to the users, even though the users are not monitoring the data by themselves. And the system proposes a concept of air quality monitoring system through mobile sensing using low-cost reliable sensors in order to record the variation of a series of gas pollutants. And the proposed algorithm the algorithm shows the process involved in the cloud platform to monitor the quality of air. Once the data gets stored in the cloud platform, the streamed data from 3 sensors are exported into Excel sheet, and these sensor values are calculated as average, and from that average we will compare the average with the threshold value. If the average is greater than the fixed threshold value, then the email notification is sent to the users. Regular analysis of the results is retrieved by ThinkSpeak, which is a cloud platform, allows distinguishing how bad air pollution is from day-to-day life. The data stored in ThinkSpeak service is processed and analyzed to send a message to the users. An experimental setup. This is the hardware implementation for monitoring the quality of air. Like the sensors such as MQ135, MQ7, and MQ8 are used, which sense the ammonia, harmful gases such as ammonia, alcohol, benzene, smoke, and carbon dioxide. These sensors are cost effective and used in outdoor environments. And the Wi-Fi module, which is attached to the Arduino to transmit the sensor data to the cloud. The cloud communication platform acts as a service for sending SMS alert to the users. The sensors periodically controlled and accessed unlimitedly from anywhere using mobiles or PCs with the internet. And these are some of the results, graphical representation of air quality. With the time, sensors with time. The data obtained from sensors are stored in the cloud and monitored by user through the web interface. The MATLAB analysis app analyzes the data to decide the appropriate email message to generate based on sensor data. The sensor data is analyzed as a result, and a data sheet is being generated. The sensor data received from sensors is represented in graphical form by using the ThinkSpeak. If all the values of 3 sensors are optimal, then the quality of air in the atmosphere is good. And this is one of the sensor. This figure shows the real-time analysis of MQ7 sensor. The cloud-based server will receive or store large amounts of information from multiple users as they
Sai
finish
Surya?
information recording sessions and upload the gathered data over the internet. And I conclude with yes, conclude. The proposed IoT-enabled environmental monitoring system for monitoring air quality has been successfully implemented and validated at various places, like in industrial areas and these places. The device can serve needs near schools and playgrounds in monitoring the quality of air the children breathe. Comparing with collection and forwarding information or data of traditional based decision, the system has low cost, low power consumption, and easy to maintain. In the future, it is better to add additional artificial intelligence for predicting the air quality using optimal machine learning algorithms or neural networks. Uh, and this the device can serve many users who are living near industrial areas and in high traffic areas. And this is my key references. Any questions?
Can you come to your proposed algorithm slide?
Okay. Yeah.
Threshold values you have taken?
From the
Threshold
research
values
papers,
you
ma'am.
have taken?
Taken from the like research papers, ma'am.
Algorithm. Come to algorithm.
Okay. Like parts per million.
These are the three values you have taken: 200, 300, 400. How?
Yes. Like it depends on sensor. Like I have checked that sensor characteristics in the website.
And delay of
Calibration.
17 seconds.
Like the sensor will give the data after each 17 seconds. The data from the sensor it will give for each 17 seconds. The data will retrieve from the sensor.
Okay, fine.
Okay, thank you for the presentation, Sai Surya Kiran. Thank
Thank you,
you.
ma'am. Can I end this session?
Yes, thank you.
Thank you, ma'am.
We'll begin with our next presentation. MD Imtiaz Anwar, I've unmuted you. You can start with the presentation. Yes, please begin.
Hello.
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 Yes, Noat, you can speak a bit louder, please.
Am I audible?
A bit louder.
Am I audible?
Yes.
Okay, thank you. Uh, so I am going to present my paper that is basically the comparative re-evaluation of different single image defogging techniques, basically a review paper, and we are going to working on the next paper, and that paper is basically under the project CRS project under TCube 3. So here are the outlines of the project. This presentation is introduction, background, existing defogging techniques, summary, comparative results, conclusion, and future scopes, acknowledgements, and references. So basically, this what is defogging due to the poor visibility, the atmospheric particle due to atmospheric particles and the atmosphere visibility becomes poor due to bad weather, and bad weather may be classified into rain, snow, haze, and fog. And basically, the mostly visibility is degraded due to the fog. So due to fog, the contrast is poor, and the colors are shifted. So the most appropriate technique is a solution to make vision enhancement system more reliable for outdoor applications like remote sensing or surveillance systems. So we have to be enhance our visibility schemes. So we have to make an appropriate technique, some sort of technique that should be reliable. So this is the diagram where how the reflection going through this scene towards the camera and how it will be degraded through the atmosphere. So basically, what is the background of that paper or the project? That day by day, the number of accidents are increasing due to the poor weather all over the world, in the northern area of the India and the similar areas in the world. So, from the data collected, that is more than 2 million people die per year in a car accident across the world, and their data is collected from the national NHSTA, that is the National Highway Traffic Administration uh, Safety and Administration website. And the total 24% accidents are due to the bad weather. Basically, most of the 24% accident that is due to fog. So we are working on the defogging scheme. So in India, we have one website that is of Ministry of Road Transport and Highways, as well as more, that provides accidental data also. The number of accidents in 2016, 17, and 18 that are increasingly drastically as shown in figure. Here, the number of persons killed by a green color, with the green color number of persons injured with the red color, and with the blue color number of road accidents. So as you see, in 2016, 2017, and 18, so it is day by per year it is increasing. It is more than 20,000 cases of road accidents, and it is increasingly towards the 30,000 cases. So we are just basically classified all the existing defogging techniques into the non-model based and the model based approaches. So in the non-model based, that is basically the contrast enhancement technique, we can say. And in the model based, we are using the restoration techniques. That means we have a foggy image and we are some sort of model we are creating. And after that, we are restoring the fogged image, defogged image for better visibility. So in the contrast enhancement, histogram equalization is there, Retinex, wavelet approach. In the histogram equalization, some researchers have used adaptive histogram, after that global histogram, and after that the better technique, that is of contrast limited adaptive histogram technique for contrast enhancement. For Retinex, the single scale Retinex, the multi-scale Retinex they have used. For wavelet approach, wavelet, different types of wavelet transformation, DWT, SWT. So there are different kinds of used in the literature. In the restoration model, where single image method and the multiple image method. In the single image method, only one image is required. That is interactive. That means the user input is required. And in the single image method, automatic, that is of dark channel para, that is most popular method is used, and that is developed by the Kamin He. That is independent component analysis, MRF, and anisotropic diffusion method is used. For the multiple images method, the fusion method, in which the two images are used. So that the two images may be the RGB, or one may be RGB, the another may be the infrared image. And after that, the polarization method is also used, in which the multiple images are used of the same scene to defog the image. So here is the table of comparative findings, what we have found from the left hand side, the author and the year of publication. So Kamin he has used single image defogging using the dark channel prior, followed by soft matting. So what are the outcomes of that method? High quality defogged image containing non-sky regions, and reducing block artifacts. This limitation of this method is it can be used for the less sky region containing areas. After that, Shai Chai Hung in 13, he has provided a technique for visibility improvement, utilizing the depth estimation, color analysis, and visibility restoration. The outcome of this method is decreased alert effects in the foggy images.
Sorry for the interruption, Imtiaz. You just have 2 minutes left to conclude.
Okay.
Faster, please.
So these all are the methods, and we are just concluded over here with the outcomes and the limitations in 2013, in 2014, 15, and 16. So he also gave the method based on HSI technique, or HIS, that is the hue, intensity, and saturation color space in spite of the RGB color space. I also published one paper here in Springer, that is uses by dark channel prior, and I also included the weighted least square filtering with high dynamic range. So the limitation, the outcome of this paper is the sharp details are preserving here, and the color quality is maintained. So these are the small sky reasons should be the limitations of this method. After that, in 2018, the author has proposed a method. The technique involves the process of Retinex algorithm and wavelet transformation. The limitation of this method leads to the artifact DWT, that is discrete wavelet transformation algorithm used to defogging technique. After that, 2018, 2018, also SSI index and PSNR. To increase the PSNR, more computational time is required. If the time required is more, so that is the limitation of this method. In 2018 here also color edge. So all are concluded within this paper we have concluded on, and we are working on the future scopes also. So the comparative analysis as the qualitative method. This is the quality. By using the quality, we have used and simulated different methods over here. It is shown, and we simulated the methods, and we are using with the different parameters. So that is the standard deviation, and this is SSIM index and entropy. So entropy is nothing but the information inside the image. How much, if the fog is more, the intense information is less. So what is the conclusion and the future scope after concluding this? That is that the defogging techniques avoid road accidents when we are creating any defogging technique. So that will basically for the avoidance of the road accident and increasing the traveling time. So that will be also avoided. So each technique has some pros and some cons. So we have to be develop an efficient algorithm that is compulsory to muddle through the several challenges. And so one of the method we are using in the next future, we are working on the fusion of that RGB and infrared images for better visibility. So we can also incorporate the artificial intelligence and the convolution neural network. That may be also helpful. So we are working on it. And this work is under the collaborative research project under the TQ3, supported by MHRD, Government of India.
Thank you. Thank you for the presentation, Imtiaz. Any questions now?
Your presentation was very good. You have included all the things which a review paper must include actually. I just wanted to ask how you have analyzed these things. Which tool you have used for this quantitative analysis?
It's future scope.
Used for quantitative analysis.
Qualitative analysis. No, qualitative is just we have to see the images. For the quantitative, we are using the entropy and SSIM, the colorfulness index, and the deviation, standard deviation. We are using for the quantitative. For the qualitative means you have to just see the images and you have to differentiate which one is better. That is qualitative.
I've done it manually.
Yeah, by seeing our naked eyes. Yeah, that is qualitative. And quantitative means the parameters you are including, such as standard deviation, SSIM, entropy. Some other are also proposed in colorfulness index, like that. That is known as quantitative, and this is qualitative. Qualitative means you have to just see the images by your naked eye, and you have to justify which one is looking good, basically.
Thank you. Thank you for the presentation.
Thank you.
Our next presenter is Siddesh Marsurkar. I've unmuted you. His presentation is on enhanced lightweight model for detection of phishing URL using machine learning. Yes, the screen is visible. We can begin with the presentation, Siddesh. Hello. Hello.
Hello.
Yes, please begin with the presentation.
Okay. Hello. Good afternoon, everyone. I'm presenting here on the enhanced model for detection of a phishing URL using machine learning. Okay, so these are the contents: introduction, problem definition, objective, literature review, proposed system, features of your URL which we are going to use in our model, methodology, result, conclusion, and references. Okay, so phishing is a cyber crime in which a target or targets are contacted by emails, telephone, or text messages by a person, hacker, you can say, the posing as a legitimate institution to force or to lure any person to into providing sensitive their data like personally identifiable information, banking information, or other credential like password of the credit card. Okay. So why this happened? Because of the in this in our technology era, this is the fastest way of gaining financial gains. Okay, identity hiding, so uh, they can be involved in various criminal activity by hiding their identity. Some novice person can do it for fame and for fame. Okay. So according to this anti-phishing report, which shows uh, in the year of 2019, how rapidly those phishing attacks are growing. Okay, the last 2 years are considered over here. Oh, sorry, last 3 years, 2017, 18, and 2019. So in 3 years, how the phishing attacks are increased exponentially, even though there are some measures, but by the side at the attacker or phisher side, they are also evolving. So those measures are not enough to tackle or completely eliminate the phishing attacks. So objectives. So fundamental objective of this system is to develop a phishing detection system, a better phishing detection system. So basically, the system with this system with the limited features. Okay, we are not using. There are many features, but only we are using limited features. We are working on limited features, and with those features only, we are going to build a model which will provide us a better security. Those are the specific objectives. So it will extract the features from the data set, select the best features. Hello. Then here we are using a boosting algorithm. So model will be built on the boosting algorithm, and it will evaluate the performance of those boosting classifiers. So this table shows the extract of the various papers in which you can see the authors, the number of features they have used, the algorithm they have used, the instances in a data set, and the accuracy. Okay, so we are mainly focusing on the boosting algorithm and the limited sets of features. Okay. So before going into proposed system, there are many features of URL like URL based features, domain based features, page based features, content based features. So many features are available, and we can extract from that URL. So we are focusing only on URL features. So URL is the first thing that is in your hand, and you can analyze that URL and extract the features. Okay. Again, there are some more features like domain-based features, page-based features, and country-based features. So why we are not using domain-based features, page-based features, and content-based features? Because we need a third-party application to extract those features, and URL features are the features which are in hands of the developer. Hello, am I audible properly?
Yes, you are audible.
Okay. So those data features, data sets of URL is going to be feature extractor, wherein features will be extracted, only URL features will be extracted. Okay, those which features will be extracted, which will be shown in the next slide. then based on those features, it's going to be a boosting algorithm, and some rules will be set. Okay, simultaneously the model will be saved, and using that model, the URL, the input URL will be tested, and it will be classified as a phishing or not. Okay, so these are the features, 22 number of features which we are using, but we are also proposing that we will use a feature selection algorithm to reduce the number of set of the features. So out of 23, the most important 10 or some features will be used, and based on that, phishing site or URL will be detected. Okay. So here we have collected a set of URLs, around 5,000 URLs. You can see the difference between the phishing and valid URLs. So the upon those parameters, upon those features, okay, we have made the graph. Okay, what is the difference between the valid and phishing features on those parameters? So if we apply those features to any algorithm, so accordingly, it can be classified as a phishing or genuine benign URL. So methodology here we are going to use is the gradient-based boosted model, GBM.
Sorry for the interruption, Siddesh. You need to
Yeah,
conclude a bit faster now.
yeah. I'm going.
Just
Okay.
2 minutes left.
Yes, I'll take care of that. The first algorithm is the gradient boosting algorithm, and second is the XGBoost. Okay, so boosting is a method of converting weak learners into strong learners. In a boosting, what happens? Each tree is fit on a modified version of the original dataset. So it begins by training a different tree, which each observation is assigned equal weight, sorry. And after evaluating the first tree, we increase the weights, and accordingly, those trees are more divided. Okay, so likewise, the secondary is grown on the weighted data, and this is the idea to improve the predictions on a first tree. In a XGBoost, the XG stands for the extreme gradient boosting. Okay, so it is again it's a based on a GBM, so it has some advanced features than the GBM. Okay, so what we are proposing here, we are building a model based on XGBoost and GBM gradient boosting algorithm, and that will be and those model, the performance of those model will be compared with the conventional machine learning algorithm like a naive Bayes, random forest, okay, decision tree. So the primary focus here is only on the boosting algorithm. Okay. So as I said, the XGBoost is an implementation of GBM with a major improvements. This algorithm was developed to efficiently reduce the computing time and to improve the optimal uses of the memory resources. Again, it allows a parallelization. So computing speed is very much high. In a lesser time, we can produce the result. So XGBoost faster than the GBM. So XGBoost uses more regularized model formation to control over the fitting, and which gives a better performance also. Okay. So in a proposed system, we are going to test the performance of the various models on this parameter, okay, on a confusion matrix. Okay, then some other parameters are accuracy, precision, recall. Along with that, we are proposing to include some more parameters like a sensitivity, error rate. Okay. So in a conclusion, I would say this paper proposed to detect a phishing website using a boosting algorithm, because phishing is a very crucial area which is continuously evolving with our technology. So in a boosting algorithm, we made we are proposing to give you a better accuracy. So in this approach, we relies on the analysis of URL and its processing, which and after processing those URL, which will give you most of the lexical features. Okay, so in this method, we are only focusing on the URL or lexical features, which are very easy to acquire, and its processing is comparatively simple. That lesser time is taken compared to other features of the URL. In a future work, what we can do is we can incorporate the small email detection, okay, with the same
Sorry,
technique.
Siddesh, you have crossed
Yes.
the timeline. You have taken more than 10 minutes.
Yeah.
We have more
Okay.
presenters left. We have para sessions going on. Please conclude faster.
Okay. So we can include email detection system. Again, as I said, we are only focusing on the lexical feature of the URL. We can incorporate many features to improve the accuracy. So as we have many features which is coming from the different domains of the URL, okay, we have a lot of choices to select important features among them. So using those features or incorporating many features, we can improve the accuracy. Okay. So these are the references. Okay. Thank you. Any questions?
Thank you for the presentation. We'll move further now. Our next presenter is Rajalakshmi. I've unmuted you. Rajalakshmi. Please unmute yourself first.
Hello?
Yes, it's audible and your screen is visible as well. You can begin with the presentation now.
Thank you.
Kindly stick to the timeline as well, yeah?
Yeah, ma'am. Yeah.
Thank you. Yeah, please carry on.
Good noon to one and all present over here. I'm Ms. Rajlakshmi Ghatkamle, research scholar from CMR University, Bangalore. And today I am here to demonstrate my research work entitled with identification and classification of foreign bodies from rice grains using digital image processing. I guess. Yeah. So these are all the contents which I'll be covering in today's topic, that is introduction, objectives, problem identification, proposed methodology, flowchart of the system design, implementation details, and conclusion and the references used. Now coming on to the introduction part, as we all know that food is the basic requirement of every living being on this earth, and rice is one of the most important food grain for most of the people living in this world. Hence it is considered as a staple food of India. But these days, adulteration of rice has become a major issue and has a distinct effect on the yield of the rice. So the proper inspection and grading of the rice is very much essential. Now, since the method of testing the food grains, what we are using these days is very low, as most of the work is done manually in our country. So the current research article depicts the method for identification and classification of the foreign bodies from the rice grain image samples using the digital image processing approach that extracts the geometrical features, color features, and texture features and processes it by using the probability neural network method. This research work is also used to overcome the adulteration problems and the frauds happening in the present marketing conditions. Now, coming on to the objective, that is the current research work is done on the existing system, wherein we are building and developing an automated system for the rice classification using the digital image processing method. Now, in the problem identification method, in the present grain handling system, as we all know that the food grain types are rapidly assessed manually through visual inspection by the human inspectors. And this manual inspection of the rice grains is followed as traditional operation of rice grading from years, which is unreliable, labor intensive, and also sometimes it is time consuming process. Because you know what happens, sometimes the decision making making capabilities of the food grain inspectors can be seriously affected by his or her physical conditions such as eyesight or tiredness, or due to some mental states caused. Also, the decision taken by the food grain inspectors can be biased, or even in terms of work pressure, they may vary their decisions. Now, as you can see in the slide, that is these are the factors that degrades the rice quality, like physical characteristics, color, shape, size, and there are some chemical characteristics associated like texture and aroma and all. And also due to pests and diseases and due to adulteration also, the rice quality has been degraded. But in the current research work, we are focusing mainly on the foreign presence of the foreign bodies in the rice grains, such as the dust particles, leaves, stones, etc. Now, coming on to the proposed methodology, that is, and giving justice to my research title, that is, efforts are put in designing the hardware model for image capturing and analysis. Here, I have built a machine-based technique using the Python programming, and which is implemented for the identification and classification of the rice grains and foreign bodies, that is impurities, that uses the PNN algorithm, that is probability neural network algorithm, to analyze and classify the objects based on its color features, geometrical features, and texture features. Now, as you can see that this is the block diagram or the system architecture that comprises of 6 modules, that is image acquisition, pre-processing, image enhancement, image segmentation, feature extraction, and knowledge base. And each of these modules I'll be explaining in brief in the further slides. Now, as per the system architecture, this is a very basic algorithm which I have tried to depict to overcome my research work. That is here initially, and in the first step, as you all can see, that rice grain image with the impurities is captured. Then the grain image is pre-processed. Then the enhancement of the grain image with impurities is carried out to remove the noise and blurring by filtering an image. And later in the next step, image segmentation is carried out and extract, and after this segmentation, the morphological, color, and texture features are extracted, and based on these extracted features, the rice grain and impurities are analyzed and identified using the probability neural network method. Yeah. So coming on to the next slide, that is the first module of my system architecture, which is the image acquisition slide, wherein the initially an image is captured of the food grain image. That is in my research, it is concerned to the rice grains and its impurity particles, and it is loaded in the disk in the JPEG format, as you can see in the image. The next is the pre-processing step. As you all can see that there are 3 steps involved in the pre-processing step, that is grayscale image conversion, RGB to gray conversion, and binary image conversion. This grayscale image conversion provides the intensity information of each pixel in an image. It is also known as black and white image. That is, at the end of the grayscale image consists of only 2 colors, that is black and white, in which black is considered as a weakest intensity and white is considered as a strongest intensity. The next step is the RGB to gray conversion, wherein, as we all know, that every pixel in an image is specified by 3 values, that is red, green, and blue. This step converts the RGB scale to grayscale conversion. The next step is the binary conversion, in which the grayscale is converted in terms of binary format, in which the pixel value with luminance greater than the label or threshold value is replaced by 1, that is, and the luminance lesser than the label is replaced by 0, that is black. These are the resulting images in pre-processing, in which the first image... Hello?
Yes, sorry for the interruption, Rajlakshmi. You just have 2 minutes left to conclude.
Yeah, ma'am. Yeah.
Yeah.
So the image enhancement, the idea behind image enhancement is to bring out the hidden details from the image, that is the features of interest. And the next is the image segmentation, wherein the main purpose of the segmentation is to bring out, that is the purpose of the image segmentation is it will check whether the value of the threshold value of the rice grain is more or no. If the pixel value which we have given, if it is more, then it is estimated as grain, or it is estimated as this foreign particles. So these are the sample images, how the grain image segmentation is been done. Now, feature selection and extraction. Here the features are extracted for the rice grain and impurity particles are based on the geometrical features, which are rice area, which are the object area, major axis, minor axis, and aspect ratios. And color features are R mean, G mean, and blue mean color features, and texture features such as entropy. Now, this is the knowledge base. All the extracted features of the rice grain and foreign bodies are from the input image, are stored in this knowledge base during the training of the sample images. And this knowledge base is later used to identify and classify the rice grain and impurities during the testing phase using the probability neural network method. So after the feature extraction process, the probability neural network method is used to perform the training and testing of the rice grain samples along with the impurities, and further identified and classified as the rice samples or impurities based on the extracted features from the given samples. So based on this neural network part, based on this equation, the probability neural network decision and classification is done. That is the summation of truth positive and false negative divided by the summation of truth positive, truth negative, and false positive and false negative terms. So coming on to the conclusion part, with the proper selection, I can say that with the proper selection of software tools, a cost-effective tool is designed for the quality analysis of rice grain images, which provides all the relevant parameters about the rice grains by image analysis. And the rate of accuracy can reach a higher and higher based on the varying rice grains. Like a few rice grains will be very long and few will be very thick. So based on that thing, we can the project can work as friendly, and hence this method not only improves the efficiency but also it avoids the insignificant algorithms and programming of the other methods. So by saying these things, yeah, so these are all the references which have been included.
The reference slide is not available. Can you present that slide?
Yeah, ma'am.
Algorithm, we are not able to see all the slides. This is just showing algorithm slide.
Algorithm slide, ma'am.
Yeah.
Yeah. Yeah, ma'am.
Data set you have taken, ma'am. And how?
Hello, ma'am. Ma'am, you're not audible. Little bit louder.
Data set.
Yeah, ma'am.
Data set.
Hello.
Ma'am, are you using any particular data set or you have taken it from somewhere?
No, ma'am. It is actually the basic algorithm which I have personally designed it for the current research article.
Taken this data, you have not taken data set, any standard data set for this. Is this available somewhere?
So, no, ma'am. Actually, data set I have not taken from anywhere. I have personally captured all the images of the rice grains. I guess around 8 to 10 varieties of rice grains I've collected from various growing environments. Actually from Karnataka I have taken, because every region has different growing capabilities. Like Raichur, if you go to see, there is too much of temperature is more comparing to the lower south side. So based on the varying climatic conditions, I have taken the rice grains from those particular regions, and I've captured my own, I've designed my own image processing system. And based on that, I've taken my own data set. So I have not taken it from anywhere else.
In that case, you have to refer that thing. You have to mention this thing in your paper also.
Yeah, ma'am. Yeah, ma'am. Any more questions?
Thank you for the presentation.
Thank you, ma'am.
We'll move on to the next presentation. Manjula Pawar, I've unmuted you. Manjula, can you hear me?
Yes.
Please begin with the presentation. You can present your slide.
Participants are required to just start from the very important concepts. Just don't take time on content slide. As such, we can go through that slide. Don't read the contents of your slide.
Yes, sir, ma'am. Yes.
Thank you. Yes, please begin.
Yeah. Everyone, myself, I'm presenting paper, study paper on blockchain scalability, along with my co-authors Prakash Gaur Patil and P.S. Hiremat. The agenda of this, the content of this goes like this: introduction and different types of the scalability improving technique for the blockchain, and inclusion and references. Introduction. So nowadays everybody is telling about the blockchain technology. So what is this blockchain technology? It is actually it is referred to as a distributed ledger technology, which makes the history of any digital asset which is unalterable and transparent through the use of decentralization and cryptographic hashing. It has become more popular because of its very beautiful features, like any because it is in the form of decentralized. Many users are coming, they are distributed, they are in decentralized, not there is no concept of central authority who is governing or managing so many different nodes. So it's a concept of decentralization. So along with that, it provides so many features, like it cannot be corrupted, because whatever data you're, because there is a ledger which is open and it is copied in all the different nodes. Whatever transaction any person writes, it is visible to all. Hence, there is no concept of corruption. It is corruption proof, and it is decentralized. There is no single point or governing authority to manage all the users. Everybody manages themselves. Enhance security. Along with the decentralization, it provides the encryption, which makes another level of security. And distributed ledgers, as I told that it has an open ledger, distributed ledger, which is managed among all the nodes. So that is one beautiful feature of the blockchain technology. Consensus. It is a main core part of the blockchain technology, which thrives the blockchain technology, because this is the one which helps them to make the decision and to make the cleverly. It is designed so cleverly that by making use of this consensus algorithm. And faster settlement, because nowadays if banking software, if they use the without involvement of any third party, people can perform the fast transaction and they can save the time. So though it has so many features, it still faces some challenges like scalability and privacy. Because privacy in the sense, because that open distributed ledger, which is distributed among all the users, it is open to everyone, it is transparent among all the users. So there is no privacy. That is one challenge. And another one is scalability. Presently, there are most popular platforms are nothing but Ethereum, Bitcoin. So many platforms are there, but they are processing very less number of transactions. For example, Bitcoin is processing only 7 transactions per second, and Ethereum is performing only 20 transactions per second. Hence, it is lacking with the scalability. The main issues for affecting the scalability are limitations, block size, response time, and fees. Limitations in the sense it is lacking with the limitation with the hardware side. Block size means, suppose if we go with the cryptocurrencies like Bitcoin network, it has only 1 MB of size of the block size, which can handle only 2000 somewhere transactions. Hence, there is a limitation with that. Response time, because in order to execute any particular transaction, it should go under first validation. So to do that validation, all the transactions need to wait in the queue. Hence, it takes some time, approximately 10 minutes time to go under this validation process. Cost. And because to execute every transaction, it should pay some amount of fees to the miners. Even if the transaction is very complicated, they feel that if the complexity increases, it has more value and the cost is also more. And if the user wants to process that very fast, then they have to pay more amount of fees. So improving the scalability is nothing but considered as the different categories like capacity, latency, throughput, and cost. So based on those different categories, it can be improved with the current technology. There are so many solutions existing like on-chain, off-chain, side-chain, child chain, interchain, and deep learning method and caching method. So in the on-chain technique is the one, it currently changes the or modifies the current blockchain. For example, it suggests that to increase the size of the block, which enhance the scalability. By increasing the transaction limit, it reduces the cost of the transmission. But still it has some limitations that as the size increases, its speed is getting reduced, and there is possibility of generation of more orphan blocks. And since by increasing the size, there will be more maintenance cost, and hence it causes the throughput issue. Hence, it is not the good solution for improving the scalability. Another on-chain technique solution is the implementation of Merkleized abstract syntax tree. which is a combination of Merkle tree and the abstract syntax tree. Merkle tree is nothing but it's a binary tree which concatenates to 2 hashes of each transaction of a block. Then further it concatenates, it hashes that concatenated the hashes. But another abstract syntax tree is another one which connects each function until all the dependencies in the program are mapped. You can see one of the example here is either Alice pub key or Bob's pub key. We can represent that in this Merkle's abstract syntax tree in this form. So if you are choosing one particular user's key, so either it will go in this direction or it will go in this direction. So other branch is kept hidden. So this leads to the increasing in the privacy because one branch is totally hidden, and it reduces the size because it grow in the form of log scale. But it has a limitation that it doesn't provide the complete privacy since it is not completely hidden. Another technique comes under on-chain is segregated witness, because most of the transactions are 70% of the transactions is associated with the signature. So it's better to separate that signature from the actual transaction. So for that, it suggests the solution that signatures are stored in the data structures called a witness, which are separated from the transaction. And this solves the problem of the malleability, and it reduces the size of the transaction, which helps to improve the throughput. But the way it has been written, it is more complex. The another on-chain technique is the sharding method. Here the nodes are grouped in the form of shard. Hence, every shard is concentrating on different kind of blocks instead of concentrating on all the blocks. And here every shard is working on the parallelizing the transactions. With that, it will improve the throughput. But still, it has some problem like 1% attack, because if any attacker takes the control over entire shard, there is a problem of one.
Sorry for the interruption. You just have a minute left to conclude your presentation. Faster, please.
Sure, ma'am. Sure. Another technique, off-chain technique, is what the main chain actually doesn't perform the transactions. All the transactions are executed after the, outside the main chain. Hence, there is a less burden on the main chain, and hence it improves the throughput. But because if there is a less burden on throughput, then definitely the fee and it reduces the fee and standby time. But the transaction fee, the limitation with this is the profits of the miners may fall, so the ecosystem may change. Another technique is side chain, which exchanges the assets between two different blockchains. For example, one of the blockchain is cryptocurrency, which takes more time. So instead of implementing in my current blockchain, I will implement it in different blockchain. From there, I will retrieve it. With that, I can improve my throughput. Another one is child chain. The most popular child chain is plasma chain. Here it comes with the parent and child structure. Every time parent starts creating the child chain, and child chain will create the transactions, and those generated transactions are converted in the form of a hash root that is stored in the root. But while keep on generating the child chain, there may be possibility of generating one bad node. Whenever there is a bad node, you can see that its processing will become slower. In that case, immediately it will go to the next chain. But the limitations with that is it's verifying the child chain is very expensive, because all the parent chains must be very honest, and the confirmation of all transactions in the child chain after converting Merkle hash is troublesome of the parent chain. This improves the next one is interchain. It is similar to the side chain, but because communication, it provides the communication between different blockchains. It provides the infrastructure for the side chain. It is same as side chain, and hence it improves the throughput. But the limitation with that is different. So many blockchains are involved in it. They all must implement the same hash computing algorithm, and they should go with the same POW, that is proof of work. If the person is very lazy, and because they are coming across one expiration date, if he is very lazy, then the exchange of that can be completed, and when the expiration date is almost reached. Another technique is deep learning. In this deep learning, we are coming across two layers. One is base layer and branch layer. In the actual branch layer, will execute all the transactions in the form of Merkle tree. And after executing that one, the hash of that will be, the signature of that Merkle tree will be stored in the base layer. Hence, it is going to become very lightweight at the base layer. Hence, it improves the throughput. And it also provides us many features like privacy, ownership, efficiency, and transparency. And this achieves the decentralization as well as throughput and low latency. But it needs more bandwidth. Hence, there is a problem with this approach also. And it uses the hash graphs while implementing. That is suitable only for private and permission chain. Last technique is caching. In this caching, it makes use of FPGA, that is field programmable gate array with a network interface controller and SHA-256, which saves the most of the hashing execution, and hence it improves the performance and it reduces the collision and enhances the system's hash table. And it uses the performance of this has been implemented using the Bitcoin core server. It improves up to 103 times of the system. Here you can see that the client is actually attached to the FPGA. When he requests for anything, it is directly connected to FPGA, which helps for improving the performance. If there is a cache hit, if it is already existing in cache, then it just reply with that. If there is cache misses, then it will approach to the blockchain server. Then it will the response will be taken to FPGA. Then that response will be given to him only when there is a cache misses. It will interact to the blockchain server only when there is a cache misses. Hence, the performance is improved here. The same thing is being shown here. The conclusion and future scope of this is all these methods are considered along with their advantages and disadvantages in terms of capacity, throughput, and cost categories. But still, the latency is another factor which need to be considered. These are the references. Thank you.
Thank you for the presentation, Manjula Pawar. As we are running a bit late, we need to move on further. Thank you for the presentation, ma'am.
Thank you.
Do we have Anagya Vaidya? Anagya Vaidya?
Yes, ma'am.
Yes, I've unmuted you. You can begin with your presentation.
Yes.
Start sharing your screen.
Yes. Good afternoon. The PPT are visible to everyone?
Yes, yes, yes.
Yeah, good. Good afternoon. My paper title is A Framework for Implementation of Learning Analytics and Education Data Mining in the Traditional Learning Environments. Currently, everyone is running for the NAC and everything nowadays. So in the higher education is the power tool to build a modern, valuable or knowledgeable culture or cultural-based society. And the primary education is necessary for the creating a base, but while higher education is extremely important for providing the cutting edge of it. And quality education is a mantra of present educational systems. To achieve a quality, there are so many factors or so many various factors are influenced for achieving the quality into the higher educations. They may be that your teaching, learning process, infrastructures, curriculums, and effective all different processes are there. And since from the last 2 decades, the education is more on the student focused rather than it is becoming a teacher focused. Student focused means what? The education is now looking for how the students are learning, what is their interest, are they are interested in that course, and as per that everything will get it changed. And for that and while in the teacher focus means that it is more on teacher centric, where the teacher is supposed to lead the process. And with reference to that, a technology also play a very important role in the teaching area. And education analytics and education data mining, these are the 2 more leading areas where it comes into the education terms. A learning analytics is nothing but it collects the information about the student's behavior, it collects the information about the student what I can say, the student assessment and everything, and do some analysis on it and present a report in the form of descriptive, diagnostic, and predictive format. This is an emerging branch since from last decade. And this for analytic process, we require a data mining techniques, and that data mining techniques are nothing but they are calling it as a educational data mining techniques. And these educational data mining techniques will be help us to whatever the data you have collected into the learning analytics will help you for identification of the learning patterns, identification of the teaching patterns, learning attitude, and so on, and present these results to your stakeholder, those who are decision-making stakeholder. We are calling it as actionable reports are presented to them. And all this process will be managed by your learning dashboard, because the process is whatever we have done, it should be visible to your end customer paths. When you are dealing with these 3 parts, I can say from 2018 onwards, a new additional driver will be come in picture. And that additional driver is nothing but it is called as a learning science. That means along with the learning analytics, along with the education data mining, learning science is the third driver come in picture. The learning science suggests us ki how does it understand how the knowledge is developed by the students and how it supports in the knowledge development, how your process is support into the knowledge development. Now this is the era of student-centric learning, not on the teacher-focused learning. So this learning science play a very, very important role in the education parts, and it emphasizes on measurement of behavioral learning outcomes as well as you can say the cognitive learning outcomes. And these outcome measures can be measured by different experts. One of the experts is a Bloom's. He suggested the 5 levels of the measurements. He has suggested knowledge, comprehension, application, analysis, synthesis, and evaluations. These are all the 5 different types of the measures are available for measuring student progress. And now a technological support is there. So LA and EDM. The LA is for the learning analytics, EDM stands for the education data mining. These are more implemented, or rather it is 100% implemented in the e-learning environment, MOOC learning environment, Coursera, or you can say the LMS systems environment where they are implementing these all the practices. In e-learning environments, you can do the measurement you can do the measurement by identifying the interaction of a student with the LMS, understanding the student problem solving approach, understanding student interactions with the teachers, because the blogs are written, and as per the blogs you can do the identification of them. You can identify the others interactions with the others, even what type of reading materials they do, what the approach towards the assignment solving, everything we can analyze and we can store. And these all inputs will give us an output of predicting the student performance, predicting the course outcome of the next year, how many falls will be occurring in the course, and so on. But in the traditional teaching environment, this type of measurements is impossible. What do you mean by the traditional learning teaching environments, which we are doing it right now? In the India, we are not moving towards the all LMS courses. We don't have, most of the colleges may not be having the learning management systems, right? So the education is still on the teacher focused. Most of the times, the teachers are just taking a written test examinations, and on the basis of memory skills and the writing skill of the students, we get evaluating the students. So it indicates me, so a proper methodology will be required, which will do these written skill examination very proper way. So we can measure the students' learning patterns. We can measure even given the teacher feedback, and everything we can measure as we measure into the learning environment. So in this paper, we are presenting the methods how we can performing these measurements, how we are implementing the learning analytics and education analysis into the traditional learning environment. For the process, for the proposed models, I have identified as 3 are major stakeholders for my systems: students, teachers, and a high-level management. Definitely, the students are more focused to know their progressions, their evaluation reports with self-awareness, with self-motivations, with the knowledge which they are earned, they are required. And the teacher are also interested for the systems to get a feedback about their learning material, about their learning tasks, about their assessment skills and everything. And with help of these 2 inputs, we can say the higher level managements are interested with reference to the student to identify the student progression reports, syllabus review reports, and course content reports, and introducing a new course into the syllabus and so on. To support all these processes, we are taking the help of the all different EDM, that is the educational data mining techniques, along with the learning analytics. The model is divided. It's a layer approach where you can say these are the vertical layers and these are the vertical layers.
I'm sorry for the interruption, Anaga. Just have 2 minutes left to conclude with your presentation.
Okay.
Faster, please.
Fine. So this is a typical block diagrams for my proposed models, and these are the different services are implemented over here. Okay, I will not go for more details. The systematic arrangement for everything how I have required. I will go for direct result and the conclusions part. We are implemented these models for any in the Pune MBA college, where to the 314 students for the first semester, they are having a 15 subject over there, and more critical parts with the major specializations, and they are having the minor specialization with me. And Excel sheets are divided into like this way. We are taking Excel sheet over here. My major contribution, I will tell it to you. It's a very the time is very less. So what coding, data coding is the major contributions. By using these different techniques, we are coding. The subject coding is there, and the subject coding will be store the marks which are available with the students part. So with the help of questionnaire, with the help of this coding, with the help of question bank, we are designing the question paper. This is a question paper part which is automatically checked by your computer form scanner, and this form scanner will be is supposed to develop your Excel sheet, and that Excel sheet is provided to the R programming, and all R analytics will be performed over here. So this is my major contributions for with the help of form scanner. I develop a software for reading that question paper set, and with question paper set, it converted into the Excel sheet, and with the Excel sheets, we are converting into the R programming parts, and finally we come up with the dashboard. This is I am developed into the R Shiny. With the help of R Shiny, we develop this dashboard where all the students will get their progress. See here, we have written the performance analytical progress, predictive analytical progress. The faculty will get their progress over here, and the higher level management will be click on that, and they will get that progress. And for that process, for the EDM, that one techniques we have implemented, the anomaly detection techniques, identification of fault which exist in your systems. These are the techniques, instruments that we can say we are used, and these are the results of that instruments. And finally, the software will come up with these tables, which will conclude that which type of these are the subject name, which type of subject is the anomaly evaluated. And same way we are performing the predictive analysis as well as the descriptive analysis also. Even the diagnostic, this is nothing but you can call it as a diagnostic analysis part over here. Fine. So I conclude with these parts.
Thank you.
Open for the
Thank you
question
so much
answer.
for the presentation, Anaga Vaidya. Thank you.
No question answer?
Any questions, ma'am? No, we'll move
Time
on
is
further.
very less actually.
Yeah, we'll move on further. Thank you.
Thank you very much.
Do we have Laiba Mehnaz? I have unmuted you. Yes, you can begin with the presentation. Her paper is on using transfer learning for detecting drug mention in tweets. Please begin with the presentation.
Good afternoon, everyone. I am Laiba Mehnaz, and I will be presenting my paper on using transfer learning for detecting drug mentions in tweets. Why drug detection? Detecting drug or medication mentions from tweets helps in various tasks such as pharmacovigilance, syndromic surveillance, and monitoring drug abuse. And hence, if we build robust systems that can detect drug medications or these mentions in tweets, we can also detect adverse drug reactions from tweets, which can in turn help these very concerning challenges in the healthcare, such as pharmacovigilance, syndromic surveillance, and monitoring drug abuse. We define a task as a binary classification task, which is simply distinguishing tweets that mention a drug from those that do not. The data set that we use is from University of Pennsylvania called the UPenn HLP Twitter Pregnancy Corpus, which was released for task 1 of the 5th Social Media Mining for Health Applications 2020 share task. This data set is highly imbalanced between the two classes, with only 0.2% of tweets mentioning a drug name. So this is also an added challenge to our experiment. So to make sure that the classifier did not become biased to the majority class, we oversampled the data set, which is provided for training and development. And the test set, as we can see, has only 35 tweets that mention a drug and 13,818 tweets that do not mention a drug, which is reflecting its imbalance. Why transfer learning? Transfer learning has recently been used to obtain state-of-the-art results in many of the most common NLP benchmarks. And since, as per our knowledge, no prior work on drug detection using this data set has used transfer learning, we decided that it would be challenging to find out the advantages and limitations that this poses. It'll lead to when we use transfer learning on a totally different domain, and especially a data set which has such a high class imbalance. All the models that we use which leverage transfer learning are based on the transformer architecture, which is now the state-of-the-art for text, unlike recurrent neural networks. Two very important points about transformer is that it allows for parallelization computation, unlike RNNs, and also the attention mechanism that is used in transformer allows to draw global dependencies between output and input. The first model that we use is the BERT model, which will also act as the baseline. BERT is the first transfer learning model that is released to the industry, to the academia and the industry for natural language processing. All the models used from here will be compared to BERT in terms of the pre-training objective, the amount of data that was used in training, and the size. We use all the models that we use from now will be equal to the BERT base size, so as to make sure that the comparison is pretty much accurate, so that all are relative in size. The BERT model, as we can see, ranks 7 out of all the 8 models that we use, and with an F1 score of 0.78. The metric that we use is F1, but not for the entire classifier, F1 just for the positive class, to understand if a model is actually performing well on the class imbalance. The pre-training data set that BERT uses is actually books corpus and English Wikipedia, which accounts for 3.3 billion tokens and a total of 16 GBs of uncompressed text. The second two models that we use is BioBERT and Clinical BERT, both ranking 4th and 3rd respectively. Both of them adapt the contextualized representations that BERT learns from books, corpus, and Wikipedia to the medical domain. BioBERT uses the same architecture, same pre-training objective as BERT, and trains on this huge data set of PubMed abstracts and PubMed Central full text articles, which adds to another 18 billion tokens. It scores 0.80 as an F1 score, which is an increase over BERT owing to the domain-specific training data that we have added. Clinical BERT further takes BioBERT and pre-trains on clinical text from the Mimic 3 version 1.4 database. This gives us a little bit jump over BioBERT, and we speculated to be because the structure of clinical text is more relatable to that of tweets than the academic papers that is used in BioBERT. The next two models that we use are SciBERT and Biomed Roberta, which rank 2nd and 1st respectively. SciBERT also uses BERT to further train on medical papers, but instead of using BERT's initial learned representations, it trains BERT from scratch, and it has SciBERT only has the knowledge of medical domain. It uses a random sample of 1.14 million papers from Semantic Scholar, and the corpus size is very similar to that of BERT's. Since it uses only its own medical domain knowledge to train on, it has its own vocabulary called the SciVocab, which has an overlap of only 42% with that of BERT's, highlighting the fact that the distribution of medical data is very different from that of the open data that is present on the web or the normal text that we use. SciBERT gives us a great increase in F1, and it is the second best model that we have used. It gives an F1 score of 0.83. The next model that we use is Biomed Roberta, which is our best model and also computationally the most expensive model that we use. And Biomed Roberta, unlike the others, instead of training BERT, it trains Roberta further on 2.68 million full text papers from Semantic Scholar, accounting to 7.55 billion tokens. Roberta in itself is a very robust improvement over BERT, as it adds a lot more data while training it. It adds data sets with more sizes and more varieties in terms of domains. And the data set that Roberta uses to train is 10 times more than the data set that BERT used. So Roberta in itself is a computationally heavy model improvement over BERT, very expensive model. And on top of that, Biomed Roberta adapts it to the medical domain. And this highlights a very important point, that our best model is also the most expensive model that we have used. The next model that we use is Electra. We have used two variations of Electra, Electra Base and Electra Small. Electra Base is of the same size of BERT. Electra Small is much smaller than BERT. Electra essentially uses the same training data as BERT and only differs in the pre-training objective. In BERT, we were using masked language modeling, where we masked 15% of the tokens, and BERT was supposed to learn to predict the word. Here, Electra points out that this pre-training objective is not efficient and uses replace token detection. So it predicts for every token if it is an original or a replacement, hence utilizing every input to its fullest. Now, Electra base has shares literally everything same as BERT in terms of the size and the number of layers and hidden dimensions and everything, and it scores just slightly above BERT with an F1 score of 0.79 and ranks 6th, which is just above BERT. And we speculate this, since all the other factors are same, this is solely because of the pre-training objective. The very interesting thing to note here is that Electra Small, which is the smallest model and the easiest and fastest to train, has the lowest performance with an F1 score of 0.73. Electra reduces a lot of parameters in their size when compared to BERT, in whether it's the batch size or the sequence length, etc. And it also takes only 1/4 of the compute of training BERT. So this highlights another point, which is exactly what we highlighted with Biomed Roberta, that the more computationally and expensive and more parameters that are present in your model will relate to better performance, which is also very risky to actually pursue in this field. The last model that we use is ERNIE 2.0, which is very different from all the models that we use. This also shares the rank with Cybert with an F1 score of 0.83. Interesting thing to note at ERNIE 2.0 is that it has no medical data while training, and it is does not have just one or two pre-training objectives like the other models. You can use your custom tasks and build pre-training objectives. So it uses a continual multitask learning framework where you can add your tasks and it learns on that. Very specifically and very intelligently crafted pre-training tasks for ERNIE 2.0 aim to capture at lexical, syntactic, and semantic features from the language, which is, when in comparison with all the rest of the models that we've used, mainly focus on capturing the co-occurrence of words.
Sorry, I just need to tell you, conclude with the remarks as soon as possible, please.
Yes, my next slide is the last slide. Yeah. And in terms of the pre-training data, which is equivalent to that of BERT's, but just a little more for their one or two pre-training tasks that they have used, and it's equivalent to the additional data that Biomed Roberta added. If we see the final results together, we see that very consistent correlation is with the computationally heavy and expensive model translates to better performance, and the one which is smallest and very parameter efficient translates to the worst performance. Another interesting point to note is that Cybert and ERNIE 2.0 share the same performance, even though they are very divergent in their ideologies to translate in a different domain. Cybert does not even take the initially trained BERT representations. It only gives it a very domain-specific knowledge, which leads to a question: are we heading towards this direction where for every domain we will have a transfer learning large model? But when we contrast it with ERNIE 2.0, we see that here solely with your normal knowledge, nothing related to any domain, solely owing to the pre-training objectives, which aim to capture a lot more understanding of the language, we can still perform equally well on any domain. And this might lead to a direction of universally domain agnostic transfer learning models. Thank you.
Thank you for the presentation, Laiba. Thank you. I would like to invite Amit Joshi to conclude the closing remarks, please.
I think it's almost about to be good evening. So good evening all. And if there are any persons from outside India, good afternoon and good morning, whatever the time zone you have in your current zone. And I thank Dr. Geeta Nalve as well as Dr. Ruchi Nanda for chairing this valuable session and listening to all the authors so patiently and addressing to them the comments which they feel regarding the sessions. It's really a valuable contribution from your side to the conference, and I hope it is difficult also, because at this digital platforms it becomes quite relevant that you need to be stick to a screen for sharing your for seeing and listening the presenters and then sharing your valuable thoughts. So thank you very much. And we have I asked Deepika to share a token of appreciation to both our chairs, Dr. Geeta Nalve and Dr. Ruchi Nanda.
Thank you, Amit, for inviting us.
Thank you, and we look forward to see your contributions in near future also.
Yes.
And
Thank you so much.
Thank you. And maybe this will turn into physical modes once we are back to our normal lives.
Sure,
And for the author's perspective, there are two things which I would like to share, that you will also receive just after this session your participation certificate, contribution certificate, and your payment receipts. As well as regarding the publication of the papers, I'll assure you that we have already sent the complete data for both the volumes to the Springer, which is the publisher currently, and we expect to complete this publication by approximately 4 to 5 months under normal circumstances, and I hope even before, because these days Springer is really working very fast, as the number of publication has increased tremendously during the lockdown period, and also they have also a new support team to handle all those things. And if there will be any queries in between, we will just let you know to address those queries. And till then, that time, please be patient. If you have any queries, just drop a mail to support@ICT4SD. Our team will be there happily to support you in the best way possible. And if you have any concerns also, please drop me a mail at the amit@gr.foundation. I'll be happy to assist you in the best possible way. And currently I am speaking from Ahmedabad, and it's raining here, so enjoy a rainy time at all the places where you are, and hope that we will see in physical to each other in ICT4SD 2021. Thank you very much. And once again, thanks Dr. Geeta and Dr.
Thank
Rajin.
you, sir. Thank you for the closing remarks.
Thank
Thank you,
you, sir.
everyone.
Thank you.
And I think, Deepika, after 1 minute, you can close the session. Till that time, if anyone wants to chat or something, they can do it.
Yes, sir. Yes.
Thank you.
Yes. Thank you for your presence, ma'am, for all the session checks. Thank you.